My name is Paudie O'Riordan. I work for VMware. I work in the storage and availability unit, and I work in the office of CTO. Why that is important, I work for the original architect of vSAN, which is Christos Karamanlis. So I'm very close to the product. Before I continue today, who here has deployed vSAN? Who here is thinking about deploying vSAN? Okay, so maybe after this session, please reach out to me if you're using the product and you want to give feedback, whether it be good or bad feedback, that's fine. My job internally in VMware is to give unfiltered feedback back to the engineers on how the product works and behaves. I come from a very operations-focused background, so I have to try to give a very, let's say, real-world experience of how vSAN works in day-to-day life, and also from talking to lots of customers. So please come talk to me after this session, and I'll take your feedback directly back to the vSAN development team. Okay. So I'm going to go straight into this today. I'm going to cover 3 or 4 topics. First, I'm going to go back over how vSAN I/O works. We're then going to take a look at the data services that we provide today and what potential costs they have. And then we're going to look at vSAN tuning itself. Again, a lot of you have deployed vSAN already. A lot of you are thinking of it. So we'll go through some of the best practices. Well, I don't call them best practices, but I will call them recommendations and what worked for people in the field, people that have used vSAN extensensively. Finally, we're going to take a quick look at benchmarking do's and don'ts if you're going to deploy vSAN into production. And then finally, we're going to go over some results that I've collected in my lab to understand the concepts that I'm talking about today. So we'll get straight into it because this session normally takes 40 minutes. Takes me 55 minutes, and I know I've only got about 40 minutes to do this. Okay. Before we begin, anything I talk about here is documented on storagehub.vmware.com. So we have 3 or 4 documents: design and sizing, vSAN, troubleshooting vSAN performance, and then vSAN performance POC checklist if you're going to do a POC. Okay. Data services. Before I talk about data services, let's understand how vSAN processes an I/O. Okay? Who here is running hybrid vSAN? All flash? Okay. So this is a quick recap on how vSAN I/O works. First, I'm going to look at hybrid vSAN. What is hybrid vSAN? You've got a caching tier full of SSDs, and you've got a capacity tier full of magnetic disks, which are generally IOPS bound. So sizing and understanding how I/O works in hybrid vSAN is going to be important to you. vSAN, as you know, is a distributed storage system. You can have one or multiple disk groups in each node, and they will all be aggregated up into one large vSAN data store that can be consumed by virtual machines. Okay. So as I mentioned, each disk group is made up of at least one cache and one capacity device. And the caching device itself is split into sections. So we've got 70% of that capacity device is assigned for reads, for all your reads coming into your system. 30% of that caching device is reserved for writes. So sizing your disk groups, especially in an I/O bound system, is something important you need to consider. So getting that sizing right is absolutely correct. If your reads are hot in your caching system, reads will be serviced from cache. If they're not going to be serviced from cache, then that's a read miss, and we're going to have to go back out to the capacity tier, pull that data in, and then read from our caching tier. So a read miss is quite expensive and can make your workload quite unpredictable. Okay. So as I said, this basically due to the latency penalty. The reads, however, are balanced between mirrors. So in vSAN, for example, if you've got 3 nodes and you've got, say, failure to tolerance equals 1, which is about the only thing you can do in hybrid. So you've got a read on node 1, you've got a mirror on node 1, you've got a mirror on node 2. We basically interleave those reads in a round-robin fashion. So you want to read from the data, you're going to read from node 1, and then you might read another portion of the data from node 2. So we'll do that in a round-robin fashion. Okay? Writes, so all writes will be processed through the caching tier, and the write cache gets destaged at 30% full. So that's 30% of the 30%. Okay? So if you've got, if I can do my maths right, if you've got a 600 gig caching device, then it's going to be about 140 gigs of that is going to be assigned for writes. And even within that, then we're going to destage to try to keep the balance, to keep the I/O balanced and regulated. We will destage at 30% of that caching tier, of that 30% write location. Okay. All flash is different in how we process the I/O. So again, it's the same thing again, but in this case, my capacity devices are made up of flash disks. That's the only physical difference as such, but the algorithm is completely different. So all writes will be serviced from the caching tier. If reads are present in the caching tier, it'll, however, like hot data, it'll be serviced from the caching tier as well. But if reads have been destaged to the capacity tier, they will be read off the capacity disks. Okay. Latency is minimum at this stage if you're going for that consistent read throughput and read latency you're looking for. Okay, the write cache tier. So 30% of that 100% allocated cache device, we will destage down to the capacity tier. So that's a tiered storage system. So all your writes will be processed into your caching tier, and then at a certain point, then we call it internally the elevator, the vSAN elevator, we will destage down to your capacity tier. Okay, so working set here is critical. If you've got a high write intensive working set, then you're going to be filling up that cache tier, and then you might have slower SSDs. And you might be bound from an IOPS perspective because your caching tier could be NVMe, for example, and your capacity devices could be low-end SATA devices because you want to save some money. Then by destaging down to your capacity tier, then basically you're going to have to make sure that you have the balance of the incoming writes from the VMs to balance out against how fast you destage down to your capacity tier, and that's what the vSAN sizing tool tries to do today. Okay. vSAN data services. So since basically vSAN 6.2, we've been adding and adding and adding to our data services and what are available today. Most of these data services will only be available with all flash systems, but such things as encryption is available on hybrid. So the main ones you will probably be looking at from a cost saving if you're going for all flash is going to be deduplication and compression, which comes as a pair, and then you're going to be looking at erasure coding. Erasure coding is simply RAID 5, which is failure to tolerate equals 1, or RAID 6, which is failure to tolerate equals 2, using a failure tolerance methods of erasure coding. Okay, deduplication and compression from an IOPS perspective is from the reads, not so much. From writes, it can be quite an overhead, for the simple fact that for every write coming out, every I/O that comes in here, we're going to have to break that down into chunks, and then we're going to have to process that I/O to understand how dedupable it is. So there's a cost to your writes when you enable deduplication and compression. We've shipped vSAN checksum since 6.2, so you would obviously leave that on by default. Encryption came about in vSAN, I think 6.6, if memory serves. So basically, at this stage, we can do encryption at rest. The key takeaway of encryption at rest is it's going to have a overhead on your IOPS, because the CPU, even though you offload to the CPU with AES, it's still going to be a cost to IOPS. Put it that way. Okay. Trim and unmap, which came about in vSAN 6.7, which is not on by default, and that has an IOPS overhead. And then QoS as well. Then you can set QoS on a per VM or a per VM decay level, meaning you can limit the IOPS. So it's fairly. It's not as feature rich as some of the some of our other competitors, but you can set IOPS limits on it. Okay, so that's a quick run through. In my opinion, deduplication and compression and erasure coding are going to be the biggest hits when it comes to vSAN performance. Encryption, yes, there is an IOPS overhead as well, but not as much. Okay. So let's look at how vSAN processes this I/O. Okay, so we'll first look at the write I/O, because the write I/O is always the most expensive in the storage system, and it's the most interesting when you look at vSAN. So your write I/O is going to leave the VM, it's going to go through your vSCSI layer, it's going to hit what we call the distributed object manager. And at this stage, it enters the vSAN system. So the first thing, the write, will get broken down into 64K chunks. Okay? The checksum is performed on 4K blocks. If you encryption, all the I/O coming into your vSAN caching tier is encrypted. Okay? So we will encrypt at 4K. And then at this stage, vSAN, the I/O has landed into cache. Fair enough? Okay, the next piece, because we have a tiered storage system, we're going to destage onto our capacity tier. Again, we're going to have to decrypt. And then if you've got deduplication and compression enabled, then we're going to dedupe at a 4K block level. After we dedupe, let's say you've got I/O smaller than 4K, then we're going to compress at 4K or lower, okay? For anything that we can't dedupe. If you've got encryption and rest enabled, then we're going to, encryption is performed on 2 to 4K blocks. Okay? And then it lands in the persistence here. So that's the story of the I/O. And you can see as the I/O traverses from the caching tier and to get destaged onto the capacity tier, you can see the effects of deduplication and compression. And you're going to see the other features coming in as well. Okay, so let's look at what you would do for your HCI system. Who here uses VxRail, by the way? Does anybody use VxRail? So 1, 2. So everybody like buys a vSAN ready node, for example. Would that be fair? Anybody build their own? Okay, so everybody's either vSAN ready nodes, or I might go with an appliance such as VxRail for vSAN. Okay. CPU. Let's consider this to begin with, because it's the most basic form here. So obviously CPU is no longer just assigned for compute. We also have to understand where it's going to fit into HCI and storage. Okay? If you've got a quite densely packed vSAN nodes, then basically the cost per CPU per VM is going to increase. High frequency clock speeds can improve CPU intensive operations such as storage. And then if you've got encryption enabled, then you would have to ensure that your CPU supports AES encryption on the BIOS, which they normally do. Most of them do at this point. Okay. Deduplication uses SHA-1, and then checksum uses CRC32. So there's this cost to CPU here, is what I'm trying to say. We do try to minimize the cost of vSAN at the vSAN storage system, but nevertheless, as you start putting on top of these data services, there's going to be increase in CPU cost. Therefore, you've less CPU cycles to process I/O, so there's going to be a reduction in IOPS. That's just the simple facts. And understanding those facts is very important. Okay. If power saving or frequency limiting, who here has a thought about power saving for their vSAN nodes? What policy should they set? Okay, so let's think about this. Historically, when servers on the HCL get shipped from the vendor, they will have a balanced mode set, which is frequency limiting. We're trying to put a balance between how much power those nodes are going to consume, and how much, therefore, how much frequency we're going to give to the workload. So, do you really want your storage system to be CPU frequency limited? Less CPU to do more work now that it's a HCI type system. Maybe you do, maybe you don't. Maybe you're cost conscious. So in this case, you want to make sure you want to keep your options open. So changing the BIOS is an expensive thing to do. If you get a 3-node vSAN cluster, that's a very expensive thing to do because you take out 30% of your CPU and 30% of your storage. So you want to get this right before you actually take the wheels off the car while you're driving down the motorway. Okay? So when you start looking at your overall server design, take this into account first. Okay, so it's controlled by the BIOS. And we also have integration with vSphere in itself. So at this stage, in my opinion, you would have OS controls set on the BIOS, and you would have your C states exposed back to the vSphere hypervisor itself. At that stage, you can set the power policy from the vSphere client itself. So when you're doing your POC, for example, and you're looking at, okay, what's the effect do I have on power savings or frequency limiting BIOS settings, then I can easily switch them to full power. Now, I'm not going to tell you that you should always run full power. I'm not going to tell you you should always run balanced. It will depend, and you're going to have to weigh up the cost of I/O per CPU and how much it affects it within your data center. But these are, in my opinion, are the most flexible things to do. I do a lot of testing internally. I'll leave these on and make sure if I get new servers that these are the settings I'm going to use. So basically, I can be quite flexible as I start running different types of tests. Okay. Memory. The primary overhead when it comes to memory for vSAN systems is the cost when you create a disk group. Okay, so KB2113954 specifies the algorithms and what we use when you create a hybrid disk group or when you create an all-flash disk group. It normally depends on the size of your caching device. So if your caching device is 200 gig or 400 gig or 600 gig, that really matters. And that's how much memory that the vSAN is going to reserve when it creates those disk groups when you create vSAN for the first time. Okay? So vSAN also allocates 0.4 of its system memory for client-side cache. So this is basically for very low latency applications. You want like client-side or server-side cache set aside, and we'll limit that to 1 gig per vSAN node. Okay, so when you do your design and sizing for VDI or server workloads or whatever the case may be, take into account the overheads of the vSAN storage subsystem, especially when it comes around to how many disk groups you're going to configure in your environment. Okay. Storage devices. So there is so many choices with the last few years on the types of storage devices you can use. You can use anywhere from hybrid, you can use spinning disks, right up to high-end, you can go all NVMe. Okay, so you can mix and match. Typically, what I see coming in from our customers, they will use a very good caching device, such as NVMe, and then they're going to use less performant capacity devices, such as SAS or SATA. I have seen a lot of service providers decide that SAS is either I can't get it, or it's quite expensive. I'll just go with SATA, and they pay the price later on because it's a caching tier. So you have a very fast caching tier, and eventually that data will have to be destaged to your capacity tier, which you'll have to go on a write to them anyway. And so you're going to have to work out the balance here. So SATA, I would generally try to keep away from. My personal opinion, I would say minimum is going to be SAS 12G devices. I work from there. and I would go for general purpose. I would keep away from the read-intensive type drives. Okay. The main thing to take away here is a single disk group is going to limit you from a storage throughput and IOPS perspective, and obviously a latency. I would go with minimum of 2 disk groups, and I'll show you some data later to explain that. If you're going to go for multiple storage controllers, it used to be a recommendation for us in the past, because unfortunately VMware decided to certify storage controllers with very low queue depth. And if you've got a lot of devices hanging off a storage controller with very low queue depth, then you're going to get some terrible performance. So most storage controllers these days are like 800 plus storage queue depth coming in. So be careful on that. NVMe, it doesn't matter, because when you insert an NVMe device, you get a controller and device per NVMe. So it's irrelevant when it comes to NVMe type devices. The other thing is to consider as well is from a CPU cost perspective, SAS and SATA devices are more costly from a CPU perspective than NVMe. So NVMe not only gives you all these wonderful new improvements when it comes to processing I/O and large and ridiculously large queue depths, but it also is a lower cost when it comes to CPU. What we're seeing in the field is NVMe for your caching devices, 3 to 4 devices per disk group, and we're seeing people deploy 2 disk groups per node. That's generally what we're seeing, because in recent releases of vSAN, we've enabled telemetry, so those configurations will get dialed home into VMware, and we can actually start seeing the results filtering in. So that's what we normally recommend. NVMe is good for the caching tier, as I said. We haven't fully optimized yet for the capacity tier. So if you are weighing up cost, then you may want to design for the future and go for all NVMe type disk group. But at the moment, I'm not saying that's the hard recommendation for me. I would say at a minimum, I go for SAS. And then finally, because it's on the screen, you can mix SAS and SATA, but you wouldn't do that, because your disk group is going to be lowered to the slowest device on your bus, which is your SATA device. And then you're going to have basically these high-performance SAS devices just sitting there, not being utilized. Okay, network. Who here uses LACP in their environment? 1, 2. Is there a reason why? Is it too complicated, LACP? Okay. So I work in a VMware Cork office. GSS support also work there, and we have a full team now of vSAN engineers. And they keep telling me that they're getting more and more network cases. And I goes, what do you mean? They're saying the vSAN is beginning to kill the storage network. Now vSAN is a network storage system. So what they're saying is people are getting like the cheap switches with lower buffers. They're not going for enterprise class, or they're putting storage traffic already on top of their existing vSphere networks, and they're suddenly paying the price. Prior to hyperconverged, you're going to attach via fiber channel or whatever the case may be. So you didn't really start looking at the network devices, you didn't start looking at firmware, you didn't start looking at NIC drivers, all that kind of stuff. And now all of a sudden, this becomes really, really important. And so what the guys are telling me, it comes in with a vSAN problem, but it goes out the door with basically a network problem. So this becomes quite critical. What they're seeing now, if you've got a Razor coding, RAID 5, all flash systems, they're saying a single thinking uplink like in a very busy system will get saturated. No problems. They said, no problems. They're saying it gets easier now with the newer devices, like the Dell's 14Gs. They probably come with 25 gig up front, so it's kind of like they're seeing lessening impact. But if you've got servers 3-4 years old with 10G interfaces, what we're saying is you're going to have to do some sort of load balancing across the two. LACP is a fit. vSAN gives you distributed switches for free anyway once you get the license, so there's no cost. It is complex to set up, especially when you talk to your network admins, but what it will give you is obviously failover, but it'll also give you load balancing. vSAN doesn't natively load balance across physical NICs themselves, so we're going to have to leave it up to the vSphere networking stack. Okay. So disk groups. So I talked about disk groups. What you can do with disk groups. So we can have a maximum of 5 disk groups per server. Minimum disk group is 1 cache and 1 capacity device. More disk groups, as I mentioned in the memory section, will increase your memory footprint. And then you can stripe. Does everybody know what object striping is in a vSAN perspective? Okay, a few. So basically, I'll take the simple example. So you can create a VMDK or a VM with failure to tolerate equal to 1. You say you've got a mirror here and a mirror here. So that's a chunk of disk. So what you can do further is to stripe that object. So instead of having 1 chunk, you can have 2 chunks. So you can have, I think, up to a maximum of 12 chunks per component. So this spreads your objects around as many capacity disks as possible. Okay? It benefits large streaming workloads, cloning lots and lots of VMDKs, big data workloads. You've got an ingestion of writes. For other workloads, more generic type workloads, you won't see the benefits as much. Okay, so that's why I'm saying increasing a stripe width often increases performance, but it really is workload dependent. Okay. Benchmarking, I'm going to go over this quickly because I'm trying to figure out the time here. Yeah, I better get a move on. Okay, who here has done storage benchmarking? It's exciting, isn't it? Okay. It's exciting. Well, it's interesting, but you have to be so disciplined in doing it. That's the trick. You have to say, okay, I need to get my baseline. It's the most critical thing you can do. Once I get the baseline, and then figuring out from your customers is, so what's your workload? And they go, it's busy. I don't know. It depends. I do a lot of writes, and then you find out they don't, or maybe they do, or they've completely underestimated it. It's very hard to do this in vSphere environments. Now we have a few tools out there with the vSAN sizer. But at the same time, a lot of this is you're going to have to benchmark for applications you know about and work profiles that you are aware of. So basically, I mean, this is all basic stuff. Small block will give you higher IOPS. Large block won't give you higher IOPS, but it'll give you more throughput. Okay? So there are two totally different workloads that would completely change the characteristics of your storage system when it comes to performance. Okay? Again, for me, the metric, in my opinion, is latency. Okay? How fast can you process the I/O? That's for my takeaway. If I look at that and say, yeah, okay, I'm kind of happy. Because then I know it can grow. vSAN is a scalable storage system. The more you add to vSAN, the more nodes is, the more it's going to scale out. This is proven in every single proof of concept we've done and every single test. Okay. This is from our telemetry data as well. So this has come from the vSAN PMs where they process this stuff. So this is the type of workloads we're seeing being deployed on vSAN. And this is the general mix here. So it can be quite varied. Okay. HCIBench. So this is what we use today for if we are talking to new prospects or to new customers that want to look at vSAN. HCIBench is a fling. You go to labs.vmware.com, and basically you're going to download the appliance. You're going to configure the workload and duration. Then you're going to use FIO or VDBench, whatever the case may be, as the engine itself. It's not our own engine we wrote, so this is free tools out there. You just need to download from third-party sites. And then this is your worker VMs. So again, I've got 10 minutes, so I'm going to go through this really, really quickly. The first one I want to talk about is jumbo frames. Y'all know what jumbo frames is? Okay, it's fine. Okay, the key with jumbo frames is less CPU. This has been an ongoing thread with several of my customers saying, like, I don't see the benefits of enabling jumbo frames. It's really hard in my existing brownfield environment. If it's a greenfield environment, yeah, I can do it end-to-end, no problem. But in brownfield, it gets tricky. Okay. These are stats from my lab. Again, I've got a low-end lab in my environment, so it's 4 node, it's 4 Dell nodes, all SATA devices, 10 gig networking. I got 2 uplinks per node. what I'm seeing when I did four tests. I did small 8K block size. I did it with default 1500 MTU, and then I set the default of 9000 MTU. So I got about a 12% increase. Yeah, it's okay. I did the same then when I did large block, so I did 60K. I went again roughly 10 to 12% increase in IOPS. What I didn't understand was the cost to CPU. Now, using vSAN observers and a few internal tools here, this is the thread for the VM kernel interface at 1500 in red. It's flat out. When I enabled jumbo frames, I got 30% back there. So that's 30% I can give to something else. Okay? So as I scale, this becomes really, really important. Okay? This is larger block size, so the increase is even bigger again. So again, it's true. Jumbo frames will help with performance. Okay, especially as you scale and you start building and making these systems more busy. It gives you more headroom. Okay? Disk groups. Multiple disk groups is a good idea. The vSAN sizer does default to do disk groups for a very good reason. Now, I can go through all the reasons why, but if you want to see results, this again is from my own lab. The details are in the graphic down there. So what I'm seeing is the orange line is a single disk group as I increase the outstanding I/O. So I started an outstanding I/O, I think about 120 outstanding I/Os per my server. I then went to 320, I then went to 640, and then I went off the scale. The latency just went. Just two disk groups. I know it's more costly per node, but two disk groups can be double the cache, and I can spread the components around the place. Well, in this case, it is much more predictable as I increase the outstanding I/Os, as I increase the workloads. It's not ratcheting it up immediately. Okay? So again, these are all based on writes. You can see the same then when we look at object striping. So I gave you a quick overview of what object striping was. So what I wanted to understand was, so these are the type of workloads it's benefiting from. So again, cloning, large ingestion of data, etc. So I started with my baseline of, in this case, two disk groups based on the previous recommendation. And then I said, okay, let me set a stripe width of 3. Why did I pick 3? The reason I picked 3 is each of my disk groups had 3 capacity devices. So when I wanted to stripe it to 3, I wanted to place as many components on those capacity disks as possible. Okay? So what I found there is I did get a significant improvement on a 70-30 mix. And I says, okay, what if I stripe even deeper, if I will go to 6? Doesn't that make sense? No. It didn't help. Okay? So striping may help in some cases, but it's not going to help. And it's not going to be the in-all and be-all. Enabling striping can be expensive on existing workloads if you want to change it. So you need to do this before you actually implement what type of policy you're going to set. Okay. Erasure coding. Everybody should know at this stage the cost of erasure coding. It's an IOPS. Okay. A single write operation for RAID 5 or failures to tolerate equals 1. 2 reads and 2 writes. RAID 6, 3 reads and 3 writes. You're going to see this when you start looking at the write workload. I mean, 44% just taken off with RAID 5. Okay? Now, what RAID 5 does give you is it gives you surety of how much space you're saving. But there is a cost to the IOPS. And it's very important. Same similar effects. Then we look at throughput and IOPS. Same general trend as well. So erasure coding is an important one when you start setting that policy per your VMs. So some VMs, it might be fine. Other VMs, you may want to stick with RAID 1. Okay. This is a graphic here to see some of the data. So on the top left, I've got my backend IOPS when I'm using RAID 1. So 100,000 IOPS, let's say. On the right, 157, straight away. Okay? Down here, these are the packets processed per node with RAID 1 and with erasure coding. You can see the graphics. It's overhead, network, and your storage devices. So you're going to hit both. Okay? So what's the time check we have there? We have 5 minutes. Okay, so I'm going to go through network. This is a video, one of my colleagues who does proof of concepts for a living, to show a customer the effects of network latency in their infrastructure. So we created a test lab in our environment, and we used stretch cluster, like a 2-node stretch cluster. And so we could traffic shape in between the 2 nodes. So we could increase or decrease the latency or whatever the case may be, with just some Linux traffic shaping on a virtual appliance. So we start off with a steady state of 47,000 IOPS with a rough latency of 6 milliseconds response time. That was combined 70-30 reads. With the traffic shaper, we introduced 5 milliseconds latency. We dropped our IOPS by a third, sorry. Okay? Once we introduced 10 milliseconds latency, our IOPS halved, and our latency doubled. Getting your network right is probably the biggest call driver we're seeing coming into support for consultants as well. Getting your network right is critical, and as we get more and more of these faster devices, as more and more performance improvements come out for vSAN, you're going to see the network become a big player here. We're seeing customers now looking at 25 gigabyte or higher. They're kind of leaving the 10 gigabyte behind them if they can. Okay, these are the takeaways here. Make sure it's healthy. vSAN controllers, firmware, BIOS, everything up to date. Benchmark what you're going to run. Don't benchmark the 4K 100% reads and say, show it to your bosses. It's fantastic. It's not. It's a lie. And we have some of our own marketing materials up there, and I'm kind of going, why do we even post that? It doesn't make any sense. Okay? The vSAN design books that I mentioned at the start of the presentation, they will help. Your friendly VMware or vSAN consultant will certainly help. Your policies, whether I'm going to use erasure coding or RAID 1 or striping, has an effect. The most significant is RAID 1 and erasure coding. Data services, deduplication and compression, for sure has an impact on the IOPS, especially when it comes to the writes. Server power settings, if you have a lab, just go try them out, it's fun. You'll see the significant difference immediately. And then when you start looking at jumbo frames, in my opinion, if you can enable jumbo frames, please do it. It's your storage. You need to keep the cost of IOPS down. And then the use of multiple NICs, such as LACP, is recommended if you can't do 25 gig or higher. That would be it. I have a few more slides here. But again, I kind of got my point across. Software perspective, vSAN isn't perfect. vSAN was pretty crap when we came out with 6.2, when we enabled a couple of data services. We got a lot of customer complaints. We've addressed some of those issues, and we're always striving release by release to make vSAN more performant. So keep up to date with your vSAN releases. Who here is on vSAN 6.5? vSAN 6.7? Okay. So vSAN 6.7 U1 came out with a lot of sequential write improvements, with or without data services. So it's something to take a look at as well if that's your primary workload. That's all I have. So I'll take questions. Thank you.